Good evening everyone, I'm Mr. Ish. Thank you for joining me for this interesting video. We're looking here at a single fun geometry question here. We have a large circle which has a certain circumference of 100 pi. Then there's this small circle which has a circumference of 10 pi. It rolls on the outer surface and it also rolls on the inner surface of this large circle. To cover the distance from the start to the finish, what are the number of revolutions that it takes for each of these travels? And we have to determine that. How do we go about doing that? If you look at the large circle, it has a circumference of 100 pi. You know 100 pi is equal to 2 pi, or you can find the radius is equal to 100 pi divided by 2 pi, which is 50. That's for the large circle. For the small circle, let's see what we can do. We have a 10 pi circumference, and that's equal to 2 pi r, and the radius of the small circle is equal to 10 pi divided by 2 pi, which is 5. So the large circle is 10 times larger in terms of radius. But what are we really talking about here? We're talking about the number of revolutions taken. If you look at this small circle, it has a circumference of 10 pi and it's going around here in terms of a 10 pi. In each of its roll, it's covering a distance of 10 pi. One roll, one revolution, it covers 10 pi. This large circle has a distance here of 100 pi. Did you need all of this? Perhaps you did not. Not for at least this outer surface travel. For the outer surface, all you're doing is basically 100 pi, because that's a distance it has to cover. With each roll, it's covering a distance of 10 pi, and you're looking at this right here. You do 100 pi divided by 10 pi, and you get 10. So on the outer surface of that circle, it took 10 revolutions. It means it revolved around its surface 10 times, such that you were to open up the circle and lay it out flat. You could cut the circle and lay it out like a line. It would take 10 of these circles to cover that distance on the outside. But what would be the case on the inside? I'm gonna write here 10 revolutions here for the outside. O for outside, then we'll do the inner side and we'll calculate that. For the inner surface, how do we determine what is the distance it's actually traveling? You would have to look at this, a new circumference which would develop as this circle rotates around. You're looking as if it's rolling and moving on an imaginary circumference, because here you're looking here at the base of the circle with regards to the surface that it's rolling on. Here you're looking at the imaginary base with regards to the circle that this small circle is rolling on. You have to calculate this imaginary circumference, because that will represent the distance that this circle will rotate and roll and move along on the inside of that circle. And how can we determine this circumference? Well, you can, because if you know you have a radius here of 50 for the large circle, and we know each of these small circles has a radius of 5, going from right here to right here is a 5, but the diameter of it must be a 10. The diameter of this full small circle is a 10. You would do 50 minus that 10 and you would give you the 40 over here. The radius of this imaginary circle would be a 40. In terms of the circumference, it will be 40 times 2 pi, which would be 80 pi. Now you have to do the distance calculation with regards to this. The small circle has a circumference of 10 pi, but it's now covering a distance of 80 pi. So you do 80 pi divided by 10 pi, and you would get over here a 8. It would take 8 revolutions on the inner surface for that same circle to cover. It would take 10 on the outside, but it would take 8 on the inside. And that'll be it for this video, and you've seen how everything is played along. Thank you for watching. Have a nice day.